Hello scientific people, today we'll be discussing about the dispersion of light and prism. So here we have a prism. A prism is an optical device made up of glass and it has got 1, then 2 and 3 rectangular surfaces and 2 triangular surfaces over here. Now when we pass light, white light from one end of the prism, the white light gets splitted up into 7 different colors and finally they come out. So by the end of the video you will also find the demonstration of it. And now what do you mean by dispersion and the action of the prism and everything I'm going to explain now. So white light actually is made up of 7 different colors. All 7 colors of light are the following. So white light, basically it is called a polychromatic light. Polychromatic means many wavelength, poly means many, chromatic means wavelength. Whereas if you consider only violet color, then it is called a monochromatic light. That means single color, single particular wavelength. Now what happens is all these 7 colors, Vibgyor, they travel with same speed. They all travel with same speed in air. This much speed in the air. But in different mediums, this is only in air or vacuum. We can consider the speed of light in air and vacuum almost the same, but the fact is that the speed of light in air is slightly less than that of the vacuum, but we will not consider that negligible amount of decrease in our discussion over here. Now what happens is when this white light, which is made up of 7 colors, when it goes inside any other medium such as glass, water, oil, the speed of all these color changes, and the red light travels with highest speed and violet light travels with least speed. These are all experimentally observed data. We are just experimenting with the things and taking it into account in our discussion. And before going into the dispersion, we will consider an example of a swimmer who wants to cross the river. And suppose this is the river and there is a water that is flowing in this direction, right? A swimmer who is standing over here wishes to cross the river and go on the other side of the river. So let me show you with the help of a scale. So the swimmer wants to exactly reach over here at the opposite end, but it is not possible because the water would be carrying this swimmer somewhere over here. Now depending upon his speed, he will be carried over here or here, right? So if this person is a very fast swimmer, he is going to stay inside the water for a lesser amount of time. So this river is going to carry this person by some distance, maybe somewhere over here. So if the person is very fast, he has to stay inside the water for a shorter time, and this person is going to reach over here. But if this person is a very slow swimmer, then what is going to happen is he is going to stay inside the river for a longer time. Then the river is going to take this person somewhere over here. So he would be reaching somewhere over here. This with high speed, this with low speed. So that means he was supposed to reach over here, but he is deviating by this much angle when his speed is very large, and he is deviating by even larger amount when his speed is very low. So if a person is swimming with a lesser speed, then he was supposed to reach over here, then the river is going to carry him over here, more amount of deviation from its own path. So from here we can say that speed is inversely proportional to the deviation angle. Deviation is a type of angle Deviation is a type of angle which purely depends upon speed. So instead of going straight, he reaches over here, so he's deviating by this much angle, right? Now same thing it happens when a light actually passes through a prism. So normally we have prism whose prism angles are 60 degree and 90 degree. So this prism has got prism angle. So prism angle, if I keep the prism like this, then the angle opposite to the base, this is the base, and this angle is called the angle of prism. So angle of prism in this case is 60 degree because this is an equilateral triangle prism, and the same I am using it over here. A is equal to 60 degree angle of prism. Now if white light falls on the prism, from here what is going to happen, I'll draw the normal, and this is the expected path if the prism would not have been present. Then this light, white light, should travel in a straight line. Okay, fine. Now what is going to happen, all 7 colors, they travel with different speed, and so all will be splitted by different amounts. I am only going to draw 2. One is red, another is violet, because all other colors will be lying in between. Now again, when they will come out, this is normal which is perpendicular to the surface, they will bend away from the normal. They will bend away from the normal. It is because of the fact that the light is going from glass, that is denser medium, to outside air, which is rarer medium, right? Okay, so they are all bending away. Now in this case, all these 7 colors are being splitted and deviated by different amounts, so they are not going to meet. So all 7 colors can be seen here differently. So if you have a screen that is generally a white background, let us call this a screen, which is a white background. So here we have one color, here we have the last color, and all 5 are present in between. Now which could be which color? So I would like to extend these 2 rays backwards, this and the emergent ray backwards. I find that this one is red and this one is violet. This is V, this is R, all 7 colors like this. Now why it is so? Because red travels with higher speed, so its angle of deviation should be less. So red speed large but angle of deviation small. This is the symbol delta for the angle of deviation, right? And violet speed is less, so the angle of deviation would be larger. So if you look at this angle, the ray was supposed to go straight, but it is now going like this, so this is called the angle of deviation. So this is the angle of deviation for red, and this is the angle of deviation for violet. So more the angle of deviation, lesser is the speed. Lesser is the speed, the ray has to be violet. Now in the next sheet we would be discussing about what happens when a single monochromatic light passes through 2 prisms, and we will understand them in quite depth. Okay, here we are seeing a spectrometer. So spectrometer is basically an instrument which is used to measure the wavelength of light, as well as it is one of a very important instrument to observe the dispersion of light too. So the name of this instrument is spectrometer. This spectrometer is made up of telescope, and here is a observer's eye has to be kept, so the observer has to look from here, and this part is called collimator. Basically telescope is a movable part and this does not move, collimator is fixed. and here we have a mercury lamp, and mercury lamp actually emits white light, and we know that white light is made up of 7 different colors. So this white light actually enters inside the collimator, and collimator actually focuses. So focuses in the sense that all light rays, if they are like this, then the work of the collimator is to concentrate, make a strong focus beam. All these light will be concentrated, and so all these light which are which have a large gap between them, it will be highly concentrated by this collimator, and then it would be imparted on the prism. So here is prism table, this part is prism table, and you can see that a prism is already mounted on the prism table. So this black color part is called the prism table, right? And when white light passes through the prism, it gets splitted up into red and violet, and finally the base of the prism is somewhere over here. So towards the base of the prism, the white light would be splitted up, and all 7 different colors would be entering into the eye of the observer. This is called slit. This part, it is a narrow opening. You can open up the screw, and you can vary the opening of this slit. So this is slit. Slit is basically a small window. You can make the slit wider or narrower, and what happens is this white light enters through the slit, whose amount can be controlled with the help of a screw. Fine. Now this, if you see from here, you will be able to see all 7 colors. That is called spectrum. Now this instrument, spectrometer, is very much useful in finding the wavelength of the light. So in higher order, in college levels, when you just pursue your career in physics, you will have an experiment in which you will be able to find out the wavelength of all the colors. So by finding, first of all, by creating the spectrum, and then by doing some of the calculations, we can find out the wavelength of the individual lights as well, right? So mercury lamp here is used as a white light source, and we see somewhat like this. So this part of the spectrum is violet, and this part of the spectrum is red, and red has got around wavelength highest, that is in the visible spectrum, 4000 angstrom, and this is 8000 angstrom, and this is 4000 angstrom, and 1 angstrom is 1 angstrom is 10 raised to minus 10 meters. So when you go in this direction, the wavelength actually increases. You can see that all 7 colors are present over here. Hello scientific people. So this is the view outside our school, and I am trying to find out the spectrum with the help of a prism. So here I have a prism with me right now in my hand, and I need to have white light, and white light comes from sun. So nowadays that this is a rainy season, it becomes hard to obtain a spectrum, and still I'll try my level best to obtain a spectrum with the help of natural light coming from the sun. And there we go. Here we have a spectrum, and we can see that the white light itself being splitted up into 7 different colors. So we can see band of 7 colors over here, and this is the spectrum. You can see all with your colors. Red is quite difficult to see over here, but anyhow we can see the spectrum. So let's continue our discussion on the dispersion as well, the second part of the dispersion. Now we have a very good question that do glass slab produce dispersion effects or not? We have learned that only the prism splits up white light into 7 colors, but it is not actually very true. Even when white light passes through a water droplet, it splits up into 7 different colors. That's what we see it in rainbow. And what makes prism so special that we use prism for obtaining dispersion and not the glass slab? The answer goes something like this. Suppose here we have a glass slab, and this is the white light which we are considering for our discussion. So this white light is falling on the prism, and this is the point of incidence, but obviously the light should split up, and it is going to split up into 7 different colors. but I am only considering two rays over here, and this one is the expected path or the dotted line, which means that if the prism would not have been there, then this ray of light should have gone straight. So this is the expected path, but we know that due to the change in medium the ray will not go straight. Now we must also identify which one is red and which one is violet. So out of these two, one is red, one is violet, and rest all 5 colors are in between. So we have studied that the angle of deviation for red is the minimum. So it was supposed to go straight, now it is deviating by this much angle, it is deviating by this much angle. So of course this is violet and this one is red. So on the basis of angle of deviation also we can state that which one is red and which one is violet. Okay, now again from here it is going to bend away from the normal. Here also it is going to bend away from the normal. Now what happens, guys? We don't see a spectrum over here. It's because all these lines are very near to each other. So all other colors which are in between, they are all like very closely packed. So with naked eye it is very hard to visible this spectrum. Definitely the spectrum is obtained, but with naked eyes we cannot see this spectrum because all these lines are very near. If you want to see the spectrum, you require a good magnifying glass, right? So that's why we don't actually prefer glass slab for producing the dispersion effect. Now here we have an inverted prism, and most of us sometimes we do get confused when a question of inverted prism comes. So let us assume that a ray of light bounces like this, right? This is monochromatic light. Consider this to be only of red color, and we can consider of white light as well. We will talk about that as well. Now where is the normal? Normal is always perpendicular like this, right? And the expected path is somewhat like this, that in absence of prism the ray would continue to go like this, but now it will bend towards normal. So towards normal means something like this. Instead of going straight, it is bending towards normal. Again from here we draw a normal which is perpendicular to the surface. Now instead of going straight, again this ray would like to go straight in absence of the change in the medium, but here the change in medium takes place, and this time the ray of light will go away from the normal because this is denser glass and this is air. So it will move away from the normal. So this is towards normal. So the away from the normal would be somewhat like this. So anyhow, we must keep the thing in the mind that the final emergent ray is always towards the base of the prism. This is called the base of the prism, right guys? And if we would have considered the violet light, then we know that instead of this ray, this is the red ray, so the angle of deviation for red is less, but the angle of deviation for violet is larger. So the violet would be somewhere over here, because the angle of deviation for violet light is more. Now from here again it is going to bend away from the normal. So what's going to happen is it will be bending anyhow towards the base as well. So if we take this as white light, then this would be violet and this would be red. And in the case of monochromatic rays, we have already understood this. Now we would also consider two more problems on the prism, which is the following. So here we have two different cases of prism in which two prisms are kept inverted and two prisms are kept back to back, right? So in order not to waste too much of time, I had already drawn this diagram, so I will quickly discuss what is happening over here. This is a ray of light which is white. It is falling on the prism, so we know that instead of going straight, this is the expected path. It splits up into red and violet color. Now when this red and violet color they go out, they will again bend away from the normal. So this one is violet, this one is red. When they again hit the another second inverted prism, what's going to happen is the red will bend towards normal, violet will also bend towards normal, and finally just below the surface they all the 7 colors, they are going to meet up, and finally the white light will be coming out. This is the white light, and the emergent white light would be parallel to the incident white light. So we can consider the combination of these two prisms as a single class slab in which just the lateral shift is taking place, nothing else. Right guys? So we might be getting confused that so what is the reason that all 7 colors, they are meeting up at this point, but they do meet up, right? If we consider, if you are still having some problem, look at this this one. Suppose these two, violet and red light, they are falling on the prism, then finally they are going to meet up over here and they are finally going to come out as white light. Just reverse this situation and you will find your answer. So it happens. Now here we have 2 prisms back to back, and now what is happening is the following. This is a monochromatic, say for example violet light. Okay, now what's going to happen is it is going to bend towards the normal. So instead of going straight, it is going to bend towards the normal, somewhat like this. Right guys? Now from here again I should make a normal, and now instead of going straight it will bend away from the normal. So this is almost going straight. Now instead of going straight it is going to fall on the prism, like away from the normal is somewhat like this, correct? And again if I draw a normal, then instead of going straight it is going to bend towards normal. So towards normal is like this, and finally again it is going to come out towards the base as the ray of light is going from the denser to rarer, so it will bend away from the normal. So the first prism had actually, for the first prism, this is the first prism, for this first prism, this is the incident ray, this is the emergent ray, so I should extend them backwards, so I get this much angle of deviation. So by this much angle the first prism is bending. Now let me actually draw the second incident ray forward. So this is my second incident ray forward, like this, because this incident ray is falling on the prism, and finally this is the emergent ray, and I should extend them. This prism is also deviating the ray of light towards its own base. So instead of going straight towards the base, this is the base, so towards the base it is the ray is bending, and finally this ray was supposed to go straight, again towards the base it is bending. So 2 prisms, if they are kept back to back like this, then what's going to happen is they are going to, both of them, they are going to work and they are going to bend the rays more and more. There is also a principle called total internal reflection, which we are not taking up here for our discussion, and we must also remember the fact that there are 2 types of prism. This is called the angle of prism. This angle is called the angle of prism, which is just opposite to the base. Angle of prism can be 60 degree, angle of prism can be 90 degree as well. Mostly we prefer an equilateral triangle prism, that is all angles are 60 degree. If we have this as 90 degree, then rest both of the angles will be 45. So hopefully you have understood all the concepts of prism, and if you have any doubts, do comment in the comment section and subscribe the channel and share the channel. Thank you for watching the video.